Alright, so here we have a Nintendo Switch console that came in from another repair shop. They always mail stuff over to us. The shop did some work to it, but he's not able to figure it out. So he thought maybe we may have a clue on why this board is not working. The shop replaced the M92 chip and replaced the BQ chip, but still the board does not turn on and he just cannot figure it out. So usually I do not like to take these boards in where a prior repair attempt has been done on the board, because you never know what could be wrong with the board. You may spend a lot of time working on it and not be able to figure it out. But since they always send stuff over, I told them to mail it in and I'll see if we can figure it out. So even though this chip, the M92 chip and the BQ chip, has been replaced by the shop, I still had my doubts, and I always like to try my own chips just to eliminate the fact that the problem could be either one of those ICs. So the first thing I did was test just to see if we have a short of any type, and we ended up having a short on this capacitor here. A short from here is related to this chip. So even though the chip was soldered by the other shop, even though the chip was brand new, it was given a short on this side of the capacitor. So before I started the video, I replaced this chip. I changed it and the short is gone. We do not have a short here now, but the console still is not powering on. So the next thing I did was I replaced the BQ chip, which is this one here. I just wanted to make sure that there's no issues with that chip, even though the customer already changed that chip. I went ahead and changed that chip again, and still nothing, no power. Right now, if I plug the charger onto the motherboard, you see the meter flickering. Look at the meter, it's flickering. There's something else going on with the board. It's neither one of those ICs, but there's something going on with the board. Now let's go ahead and test for a short again, just to make sure we do not have a short of any type on the board here. And usually there are a couple of areas that I like to test. We can start with this capacitor, it's good. The reason I'm testing those three caps because they are going to the chip, and any problems with the chip will short out the caps. Now this cap was short from the beginning, and now it's not short anymore. And we do not have a short on this cap here, which is a good indication that we do not have a short on the TV out chip that we have on the back here. But we're going to go ahead and test it anyway. And I do not see anything obvious here. So what is the problem? What is the problem? Why is the meter flickering and the console not powering on? We're going to have to do a thorough inspection on the board. Let's start measuring here. I know I already did, but we're going to do it again. No problems here. We do not have a short at all. I'm gonna test the continuity of this component here. And it's good. I'm looking for possibly components with bridges or missing components or anything that can affect the functionality of this board. And I do not see anything obvious here. Board looks clean from this side. What I want to look at is back of the board, specifically this area here, this area back of the board, and also this area back of the board. Sometimes heat in the front can cause issues from the back if you're not careful. Okay, and just securing the board in place using the magnetic holder. And look at that. Do you see what I see? Do you see what I see? We have a missing component here. We have a missing component here, and this probably happened, most likely happened, because of the way this was placed on the board holder. I do not know if we have anything else missing. It's always wise to look on edges of boards when you are having issues, just to make sure that there are no knocked off components. The board holder I'm using is not going to affect any components because look at how high the magnet is. I always like to use magnetic board holders when I'm dealing with a board that has a lot of components on the edges, because look at how high the magnet is. It's not going to affect any components on the sides here. A lot of board holders will just knock off components from the edges when you try to seat the board inside the holder. We do not have an issue here, but let's continue with our physical inspection, specifically edge of the board. See how we have a lot of components on the edges? Sometimes excess heat on front of the board can affect components on back of the board. So a lot of heat can do damage. That's why we have to check components on the back to make sure nothing is out of place or nothing is missing. So far the board looks clean. See how we have a component here? We have to make sure to check all edge components, make sure everything is in place. So anything else missing? Let me check the donor board just to make sure that this is the only component that we have missing. We may possibly have, I do not like how this component is touching here. And I see a lot of flux here. I do not know if this area has been worked on or if flux just made its way from front of the board to back of the board. Soldering looks factory here. But this component is touching this component, and we have a missing component here. I cannot recall if we should have components on the side here. Let me look at a donor board. Oh yeah, right there. We have two missing components here and one missing component here. So we have three missing components. Was that filter on the customer's board? Yeah, we did have the filter. So we have three missing components. 1, 2, 3. And this one is empty by default. Let me just make sure. Yes. Okay, so I think we found our problem. Great, great. And I forgot to check this component on the donor board just to see if everything looks good here. And we're not supposed to have a component here. So the one from the bottom, it flew all the way to the top. Look at this. Look at how we only have 1, 2, 3 caps here and a pad here. So 1, 2, 3 caps, and there should be a pad here, but it looks like the capacitor, it shifted upwards and got stuck on here. Okay. We found out the problem. Okay, at least we know what the problem is. This capacitor probably most likely it shifted from here and not from here. It's hard for the capacitor to shift from here and then make its way upwards like this. So probably one of those caps. Before I remove it, let me prep the pads, add some solder. Hopefully that will fix our problem, unless there's something else going on with the console, where we have affected BGA chips or stuff like that. We do not know how much heat was applied onto that board, but there's a very good chance that we may be able to get this console fixed based on what I see here. I mean, that's why I was so specific in the board holders video where I mentioned more than a couple of times that be careful when you use board holders. You can end up knocking edge components, and that's how I was rating the board holders. I rated each board holder based on many factors, including safety of components not getting knocked off by mistake. Okay, so we have enough solder on those pads. Let me grab the narrow nozzle and just focus heat on that specific component. And I would say maybe 390 is a good temperature. We do not want to overdo it. And it's really stuck on that pad. That's one of the caps. Now we're gonna grab the other cap from the donor board, from right here. Very nice, and we still have one more cap to go. And it's this one here. I do not have this board held by a board holder, but it doesn't matter. I just want to grab this cap. .390 temperature is really low for unleaded solder. It takes more time to desolder a component, but I do not want to change the temperature right now because my hands are full and I do not have a third hand, unfortunately. Will that solve the problem? I have no idea. I have no idea. Still blinking. I have absolutely no idea why it's blinking. We may have other issues with the board. I mean, that's why I do not like to work on boards that have been worked on before. If components were knocked off back of the board, 3 components, just imagine how some of the BGA chips will be like, some of the solder balls on the BGA chips. I think I'm gonna call it quits on this one so I do not waste a lot of time on it. But I'm just going over it quickly to see maybe if we missed something. At least I got to show you what could possibly go wrong if you are not careful. Maybe I'll go over this strip one more time for the sake of doing it one more time. I need to change that nozzle. I mean, this is not a BGA chip, but I treat it like one. where I tap it. I just push down on the chip. Still the same problem. Same problem. I'm thinking maybe I should just run over that BQ chip once again. I mean, I do not like to give up on things easy, but at the same time, I do not like to spend a lot of time working on one specific device, especially if I do not see light at end of the tunnel. We're gonna cover this connector with the foil tape so it can reflect heat away and not burn it. And let's go over this. And just go over it one more time. Pin number 1 should be on the bottom right. Okay, so the chip is soldered on perfectly. Let's just clean up. Still the same flickering issue. So it's a no fix. It's a no fix, and this just goes to show you why I do not like to work on boards that has been tampered with. This board would have been fixable if it was not tampered with, but we do not know what's going on, what else is wrong with this board. Obviously there's something else going on, and we're not going to be able to figure that out, or it's going to take a lot of time to figure that out. And I spent enough time on this console, and that's it. Time is up. So I hope you enjoyed the video. Don't forget to like and subscribe, leave a comment if you have any questions, and we'll do something else in the next video.